So in this first section, we're just going to kind of look at what length, area, and volume are. And primarily what I'm trying to focus on there is what units are involved in terms of the metric and the imperial system. And further to that, we'll also look at other quantities, and based on those quantities, be able to identify what phenomenon they describe. For example, if you had watts, for example, what does that mean? And then we would talk about how watts are a unit that measures or describes power. So these are the kind of things that we're exploring. As a disclaimer here, I'm not expecting you to know every single meaning of every single unit out there, because that'd be unfair, and I'm pretty sure that you could find many units that I would not be familiar with. I find new units all the time that are not commonly used, and got to navigate through them, and that's just the nature of being in a technically oriented field. So when you write down a physical measurement, it's really important to me, but not just to me, but in general, in any technical environment, you need to describe the number correctly and the unit part correctly. And you'll see that when you're writing your assignments or tests or whatever, I'm very strict about looking for those things, making sure that your answer is presented with the correct precision or accuracy in terms of the number, and also the units are communicated correctly. You might be like, well, I got the number right, but who cares about the units? And that's what this whole chapter is about here. This chapter is all about the units. It's making sure that you really respect the importance of it. If you're wondering, when are we actually going to do more application-oriented questions involving this stuff, that's going to be in the next chapter. So this chapter is really just laying the foundation for communication, and then the following chapter, which we'll do next week, is going to be where we actually do a lot of calculations. So this chapter is a bit more passive in terms of how much, I guess, writing you have to do and how much calculator work you have to do. There's a lot of information that's packed into this first section. My intention is not to read every single thing here. I'm just trying to highlight key things. As you can see that I preemptively have already highlighted some things in yellow here that are of most importance in terms of what I want to come across in my delivery here. In terms of the unit systems, we know that there's both the metric and the imperial system that we need to navigate through, especially when we're considering disciplines that are related to the construction industry. So that's why, it's one of those rare situations where you have to deal with two unit systems, not so much in other disciplines like economics or finance. But here, unfortunately, we have to deal with it because we're trying to facilitate building, which is worldwide, and also, of course, depending on where you are, you're going to be using different unit systems. So the metric system also has an alternative name, which is the SI system, or System International, said with a French accent though. And their bases are very different, but really the main thing is, I'll just want to mention for the metric system, is that the information in the metric system is connected, the base units are connected very much to things that are power. There's two things that are good about the metric system especially, which are that they're based on powers of 10, and also the quantities, several of them are related to water. So for example, the Celsius scale is connected to water temperature. So 0 Celsius and 100 Celsius help us have a reference point with respect to water in terms of its boiling and melting points. The chapter also continues to get into both metric and imperial system information regarding length, area, and volume. So in the subsequent topic here, it's just a discussion about length, area, and volume, specifically with emphasis on what it means in terms of conceptual meaning, but also in terms of the common units that are used. In terms of length, you should be familiar with the following units, which are in terms of the imperial system, we have inches, feet, yards, and miles. And in the metric system, we have common ones, especially in construction, like millimeters, centimeters, meters, and kilometers. Although there are other intermediate quantities as well, these are the ones that most commonly are used, especially in our discipline. And you've seen through our evaluations, assignments, and past examples in lecture that I tried to get you exposure to converting within each of the systems thus far. I really haven't had you convert across systems too much. Like I haven't asked you to go from inches to meters yet, too much at least. But we will be covering a lot of that in the next chapter. So if you're wondering when are you going to really build up those skills, that's coming soon. In terms of area, which is the next page here, the key thing is that the quantities, as you can see, are squared. Excuse me for one. So the quantities here are squared, and that's really a giveaway about area. There are a few exceptions, and you might think about those, like what would be a quantity that's an area but doesn't have a square in it? Can anybody think of a quantity that represents an area but does not explicitly have a squared, an exponent of 2 in it? Let me know in the chat. What do you think? A quantity that is area but does not have a square in it in terms of how you write it. Circle. Uh, Marco, it's a good guess, but I was thinking of something that's not a circular shape. But it doesn't. Okay, think of farming. Think of farming. Anybody think of farming? Think of real estate. Okay, it's a tricky one. It's not one that you would think of. You know it. When I say it, you're gonna get mad because you know it. It's acre. An acre. An acre is a measurement of area, but doesn't have a square in it. I'll just type it in the chat. Acre. So for example, like there's other ones. Like I have yeah, a hectare's another one. Very nice, Nicholas. Nicely done. Nicely done. Yeah. Hectare's another one. So that's a you can see that acre kind of represents something on the scale of a property, for example. Like if you have a, I don't know, a big backyard, you might have like a 0.5 acre backyard if it's pretty big. Hectare, we're talking larger areas. So things like the size of like a national park or something, or a forest or something like that. When they talk about unfortunate situations like a forest fire, they might say so many hectares of land were affected. These are scale values, so that's a great answer there. And in terms of the next level, we have volume, and I'll prompt you with the same question again, with a similar question. So volume just typically we'll see quantities that are cubed, as you can see down here, like centimeters cubed and cubic feet, etc. Now, can you think of an example of a volume which does not have a cube or a 3 in the exponent? Any examples that you can think of that do not have an explicit 3 in the exponent? This one's probably a little bit easier. Yeah, ounces, yeah, ounces. Ounces, quarts, right? If you're donating blood or something, gallons. We can have some fun there, Marco. We can have um, imperial gallons, sorry, Canadian gallons and US gallons. That's a thing. We can also have liters. That's the one that's mentioned down here is liters. And again, these are all things that are not intended to confuse, unfortunately. They were meant to be of a level of convenience because they were so commonly used, but ends up from the mathematics side confusing people. And don't worry, if you're like, you know what, I always get confused about how you convert when you have like, I don't know, gallons and you want to go to cubic meters or something, and you might be like, do I cube it or what do I do? So all of those things that might be on your mind about the unit conversions, I promise you we're going to sort all those unit conversions out next week. So, and I'm very diligent about how we go about that. Let's take a look here and see what are kind of more of the communication oriented type questions that you might see in terms of this. This is actually a very strange topic for me to test you on in an online setting at least, because you have Google and you can just Google it, and that's cool. You know, I realized that when I make tests up for students in the past couple years almost, um, I realize that you have Google in your hands if you have your smartphone or whatever, and that's cool. Like, I'm not saying don't use Google. I'm just saying that I'm probably going to minimize the amount of questions I will ask in terms of assignments and tests regarding this. As I mentioned to you back in September, the primary thing I want to do with you in this course is give you application questions and give you questions that involve a lot of technical calculations. And in terms of justifying your answers, um, by showing that technical merit, you in effect are also demonstrating the underlying knowledge of how the units and the quantities are interpreted. So there's a lot of different questions you could be asked here. Like, take a look here. Identify the type of unit quantity and the unit system for each of the following measurements. So you see here we have some cubic feet, we have kilometers, we have square inches. So when you see quantities like this, I'm not going to test you on it, but I'm going to ask you, you should be aware that this is a volume, this is a length, and this is an area. These are the kind of things that I implicitly am expecting you to understand. Now you might be like, well, what if you encounter some weird unit that you've never seen before? Don't worry, I'm not gonna give you questions that are obscure. So if you're wondering what do I mean by like some obscure, relatively unknown units, we'll take a look here on the next page. So if you look here, this is I've highlighted in yellow. So when I'll post this on Blackboard at the end of class. There's a whole list of them in the imperial system and a whole list of them in the metric system. We're going to see a lot of different tables and such in this booklet. And if you're worried about like how to organize or catalog it, don't worry. If you look on the side here, I actually don't, I have it in the actual notes, a summary of all of these quantities. So anyway, that's fine there. So in terms of the two unit systems, there are certain quantities that are very straightforward for you to remember. Like if you see inches, feet, yards, miles, I expect you to know that those are imperial system. And if you see anything with meters, whether it's millimeters, centimeters, meters, or kilometers, things like that, I expect you to know metric system for those. But some of them down here, they might be weird for you. Case in point is this one here, PSI, or pounds per square inch, or perhaps foot pound, or perhaps some of this one down here, which if you haven't studied physics, is not as obvious to people. For example, feet squared per second, or for example, down here, we might have kilopascals and quantities involving density. I think, although density, I do believe you get a lot of exposure to in other courses. So anyway, I'm not going to ask you to a great extent, especially on a test, if at all, to describe these things. In the worst case scenario, I might give you a 1 on a test and just say, what does it mean? What unit system is it, and what does it mean? And nothing too out of the ordinary, and perhaps something that you could look at the units and figure out without doing without too much background knowledge. So when you see something like this here, for example, let's take this one here again, feet squared per second. So that's an area per second. So in the example here is how fast an area is processed. So for example, spray painting a wall. Feet per second, for example, the one that comes to mind is when I used to mow the lawn all the time. It'd be, well, when I'm pushing the lawnmower, I'm probably mowing about, I don't know, 3 or 4 square feet a second if I'm going really slow. So those are the kind of things that are more tangible, that you could invent a scenario in your mind that helps you understand the meaning of those units. So there's other examples here too. One interesting thing is that your background with formulas, from whatever prior experiences you have probably seen formulas along the way, and those formulas that are, kind of random or scattered from all over the place in science, for example, they can help you understand units. Now, maybe the one that here we'll talk about is density. See, density, most people in the Ontario curriculum would have seen density in middle school somewhere, and then maybe not again until, if you're taking chemistry, for example, in high school, you would see it again in grade 12 or grade 11. But anyway, density is a quantity that you can look at the units and identify the formula. And what I mean here is like this. Density, let's just make it larger there. Density, for example, is pounds per cubic inch. I know pounds represents mass, and I know cubic inches, the cube really gives it away, is volume. So we have pounds per cubic inch, or mass over volume. So sometimes the units, if they're this extensive, that you have pretty much the formula given to you. So if I said to you, the units of pressure are newtons per millimeter squared, if you have a little bit of knowledge that newtons represent force, then you can say that pressure is force, and then meters squared is area, so force per area. Another unit for pressure, as we saw on the previous page, was PSI. PSI over here, or was it? See, PSI, which literally stands for pounds per square inch. And that is a formula, see? Pounds per square inch. Now, pounds I mentioned was a mass. One of the interesting or quirky things about pounds is that it also, in the imperial system, can represent mass, and it can represent force or weight. That's a little bit confusing. For those of you that will continue with Math 1146 next semester, which is, I'm assuming, all of you, but I don't know what the pathways hold, um, you will do a lot of discussion involving forces and such in one of the chapters in that course. Yeah, that's about it. Oh, by the way, if you do take Math 1146, there's a good chance you might have me again as your professor. So I'll put that out there. I don't know what the percentages are, but I'm guessing it's probably around a 20% chance. I don't know. There's no five-sided dice, so I was gonna say roll the dice there. Anyway, the questions here in the exercise section, you can see that they're just communication oriented. Like, write down the unit abbreviation, describe the physical quantity. There's a whole bunch of them. I kind of highlighted, like, I don't know, about a dozen of them or so. So what we're gonna do now for the next, I don't know, 20 minutes or so, maybe less, is just discuss these units. My goal is to finish up sections 5.1 and 5.2 today. And then in the remaining time, for those that just arrived, in the remaining time, I'll spend time talking about the test. I'll probably just walk you through the solutions to the test in its entirety, and that's pretty much it. And then at the end of class, as I mentioned before, I'll release the tests as well, so that you can release the grades as well, so you can see your grades. Okay, so let's take a look at the first question. Okay, write the unit abbreviation for each of the physical quantities, and try to give the physical quantity being named. So this is going to be a very light exercise here, hopefully. 68 feet per second. Can anybody tell me what physical quantity that describes? Any takers on that? What is feet per second? Okay, so feet per second, if it was acceleration, the second would be squared. So it's not quite acceleration, but you're close. You're close. Yeah, speed. If you said velocity, that's fine too. I'm not going to be, this is not a physics lesson, but velocity would be, is fine for an answer as well, because velocity has direction in it. Okay, 4730 kilograms per cubic meter. So we have kilograms per cubic meter. Any suggestions on that? Okay, there's a lot of good answers there. I think Oakley is probably the closest. How much something weighs in a given space. So density is the correct answer. Thank you, Nicholas. So you see how Oakley, you see how your answer was pretty close. But the only word that I would change is from weight. I would say mass. So how much mass there is in a given space, or mass per volume. So that's good. Those are some good comments. Okay, 80. What the heck's going on here? Sorry, I'm trying to clean up my screen here. As you know, I run like 3 desktops, so it's a little bit weird. Some days I run 2 desktops, some days I run 3 desktops. So today I'm doing extra special. 85.5 kilocalories per hour. Now you could write hour like this, or you could write hour like HR. I'm used to writing it as an H, but if you wrote H or HR, we're both good, okay? Yeah, Tamerlan, that is correct. It's a power. So power represents energy consumption. And if you know anywhere about calories, calories is a form of energy. I mean, you might most commonly see calories in terms of when you're exercising or perhaps eating food. You'll look at the labels and it'll say so many calories of energy. And then that's the energy that your body converts into useful work to do things. But yeah, power is the correct answer there. Okay, dollars per ton. $96 per ton. What the heck is that? What does that represent? So this is not like so it is a the ton definitely ton represents mass or weight. That's good, Nicholas. So this is money or value per ton. So it's like a cost per weight if you want, or a cost per mass. One way to say it is to say unit cost. That would be one of the answers that you might see in the book. I would say here cost per weight. I think that's a cost per unit weight or per unit mass. I'll say cost per unit mass, but you can use the word weight interchangeably because ton is an imperial quantity that represents both mass and weight. Okay, how about the last one here? 1360 watts per square meter. That's perfect, Oakley. Now, if I use my drawing stylus to write that down, I'm going to take forever, so I'll type that. I like what you said. So I'm going to say here, power per unit or per square meter. So an example that you might consider there is a solar panel. A solar panel I guess if in the case of a solar panel, it's power, it's watts per square meter. It's how much power is produced by the panel per square meter. It's related to energy, so power and energy are not the same thing. I'll just mention that down here. So energy, power is the rate of energy consumption. Or production. So power and energy are closely related, except that in this case, time is the difference. So you could represent this as you could use energy in the description by saying that, for example, a solar panel, if I'm using that example, produces 1360 joules of energy per second per square meter. So you get like a layered units there. As I mentioned to you, we're not looking to do too many dangerous things in this first section. Just having some familiarity with the different units and not really getting too stressed out about these calculations or communication. For each of the unit quantities listed below, what type of quantity is it, and give the unit system. I'm going to type these ones probably faster than I was trying to scribble that with my pen. So let's take a look at the first one here. So the first one is 7 meters squared. What does that represent? Does that represent power, energy? What does that represent? Area? Can you tell me if that's metric or imperial? Is perfect. Now, on my word processor is capitalizing everything here, but you don't have to capitalize the word area. How about the next one? Nicholas is on a roll today. Metric or imperial? Okay. We can't have Nicholas have too much of a streak here. It's kind of scary here. This early in the morning. It's some good skills there, my friend. All right, so someone break Nicholas's streak here. What's the next one? Oh, Marco, why'd you do that? Oh, okay. It's not length though. It's volume. Yeah, because you see the cube here? The cube gives you volume. Is that a metric? Thank you, Oakley. All right. And Joseph, thank you as well for the volume there. I didn't see that. Sorry, I was a little slow there. How about the next one? Liters. What's up with the liters? Yeah, that's a volume. Thank you, Temerlan. Volume. And that's metric or imperial? Metric is correct. Finally, we have hectares. Is hectares is an area. We talked about that before. Thank you for that one earlier. But is that metric or imperial? Yeah, it's metric. Hectares is metric. Hectares are representing a certain amount of square meters. I believe it's 10,000 square meters. I don't use hectares often in my work because in construction, sorry, in aerospace, for example, things are not that big. So anyway, let's see some more questions on the next page that I've already highlighted. For each of the listed quantities below, what type of quantity is it? So I'll do the first one just because to kind of break the ice here. Temperature. Your turn. Hours. What's hours? Time. And then the next one. Hours, correct. So HP stands for horsepower, for those that are not sure. Okay, how about the next one, RPM? Don't mind me putting these X's here. I'm just trying to line them up. It's related to rotation. Let's do a little bit better than that, but you're close. You're close. Revolution. Yeah, okay. Getting closer per minute. Thank you. So by actually saying what the actual quantity is, you're actually giving the answer here. See, this is going to be rotational speed. And that's because we have revolutions per minute. Sanjit, good morning. Don't worry. We didn't do much. We're doing some straightforward stuff. How about hertz? What's hertz? Anybody know what hertz represents? Nicely done. Nicely done. Oops. Yeah, it's frequency. When you're using your cell phone, that's probably the place that you most likely will see frequency, which is I think in megahertz or gigahertz. Like when they say 5G or something, they're talking about a frequency at which the information is communicated from your phone to a cell tower and vice versa. Anybody know where 60 hertz is common? 60 hertz is a very common frequency. Where do you see 60 hertz? Excellent work, Sanjit. Yeah, it's done in monitors, televisions, exactly. And if you have, I remember getting a TV a long time ago, and it was I think it was 120 hertz. There, anyway, hertz is the more frequency that you have on a monitor, the greater the frequency. Obviously, the more that the image appears seamless to the human eye. So if a television had a frequency of 4 hertz, then you're looking in a situation where you would see like flashes on the screen. Wow, 165, yeah. I remember buying a big screen TV. It was a plasma TV about 10 years ago, and it was 120 hertz, and it was the big thing because that was like for watching sports or something. Anybody know frequency though in construction? Forget televisions for now. In construction, where is frequency a very important measurement or instrument? And that would be earthquakes. Does anybody know what a typical frequency is for an earthquake? Because a frequency measures how fast something vibrates every second. So when there's an earthquake, the ground is vibrating every second so much. So does anybody know what a typical frequency would be for an earthquake? You can look it up online if you want. Just take a moment and try that. It's probably low double digits, high single digits, somewhere like 10, 20 maybe, tops. Anybody Googled it? Yeah, see about 10 hertz. The reason I know typically the frequency for an earthquake, 10 is kind of on the high side. That's why I was saying it's probably low double or high single digit. Because at that lower frequency, if the frequency was very high, then it would not be close to the resonant frequency of the structures that we build things with. But when something is vibrating, for example, I'll put less than here. When something's vibrating at less than 10 hertz during an earthquake, it more closely matches the natural type frequencies that exist within the building, which is why which is why earthquakes are so dangerous. Not just because of the energy input into a structure, but also because they closely match that resonant frequency. Kind of like when when a person, like, you ever seen that where the glass shatters when there's an opera singer singing or soprano, and then the glass shatters? Kind of that effect as well. Anyway, someone mentioned acceleration earlier, and that's this one here. I think it was Nicholas, I wasn't sure. But that's acceleration, and we have the squared. Okay, CFH. what the heck is CFH? So that is going to be a volume rate. Okay? Flow rate. Because that's cubic feet per hour. So a flow rate is like volume per time. I'm going to just shrink that down a little bit. And finally, last one, GB. That's not Great Britain. GB. G stands for giga, and capital B stands for bytes. George Brown. Joseph, that's a great answer. That's a great answer. That's a great answer. But it's gigabytes. It's gigabytes, okay? So gigabytes is storage capacity, or if you want, I'll say storage capacity. You might see something like maybe information capacity or something like that. Yeah, so GBC, gigabyte capacity. I like that. Okay, there's one last question here. It's talking about the construction industry. So it says here, just read the question for a second. I'll be back in 20 seconds. Okay, so what's the discrepancy here? What the heck's happening here? We have a dispatcher saying deliver 5 yards. So what's the issue here? So the issue here, any thoughts about that? That's right, yards is a length. So what's happening is when they're saying yards, they're saying they mean cubic yards. So what they're saying is 5 cubic yards. It's not, Marco, it's not even as bad as that. But it's just 5 cubic yards. That's all they're saying. So it's just laziness. It's laziness. It's inherited laziness. I'll give you another example. Okay? So my mom is a tailor. So when she goes and buys fabric to make things, she goes and buys so many yards of fabric. Like I'll say it here, okay? Let's do another example. Tailors buy yards of fabric, but what they're really buying is square yards. So the word yards here is also mistaken. So that's like strike 2. Imperial here, strike 1. Imperial again, strike 2. So the thing that comes out of this first hour mostly is that you can identify when someone is communicating information now, if it makes sense or not. And in the situations where it doesn't, you need to fill the gaps in yourself, but not based on just like not just based on intuition, which is great, but also based on the experience of seeing examples here as well. So it's 9:45, and we have completed the first section. So why don't we take a break for 10 minutes, and then we'll resume with the next section, which will be a very short lesson. And then with the time remaining, I'll discuss the test with you. So I'll see you back in 10 minutes, okay? We'll do an early break now, and then we'll continue class after that. Yeah, I'm gonna talk about test 1 at the end of class. I'm gonna reserve some time at the end of class for the test. So when dealing with manipulating unit quantities, with addition and subtraction, those quantities have to represent the same physical meaning. So for example, it would make sense to add 8 meters plus 4 meters because those are both meters. It would even make sense to add meters with inches because although they're not the same units, meters and inches both represent length. However, something like this, which is highlighted here, we have a speed or velocity, 50 kilometers per hour, added to an area, which makes no sense. It would be like adding temperature with money. Would you ever add 20 degrees Celsius plus $7? That makes no sense. So these are a lot of these calculations, you don't need expert intervention to figure out that they're meaningful or not. Your intuition and experience will tell you that. In terms of dividing and multiplying though, you can pretty much divide and multiply whatever you feel like. But the thing is that although there really is virtually no limitation to what you can create in terms of units via multiplication and division, whatever you do create or use or apply should have some meaningful um, information for you. So for example, I just wrote something on the side here. Dollars per degree Celsius. That's not a very common unit to have, but it is possible. So can you think of a scenario where you might have dollars per degree Celsius? So this is really up to just, I guess, creativity or whatever, right? Let me know in the chat. Dollars per degree Celsius. What the heck could that represent? It's a tough one. I literally just picked two random units and I put them into a fraction without any real thought behind it. I just wanted to see what we would come up with. Sheldon, I was thinking the same thing actually. Same thing with Oakley. Talking about heating a home was the first thing that came to mind, that when you raise your thermostat by half a degree Celsius, it's going to cost you an extra, I don't know, I'll make a number up, an extra $70 a month or $60 a month or whatever. Oakley's comment as well, same idea. If you want to thaw something or heat it, it's going to cost you so much energy, and energy is worth money, so we can get dollars per degree Celsius that way as well. It's great. Fantastic. Very, very good comments. So I'm going to just dive into the exercises here without too much delay, and we're going to see how this works together. So the first exercise is here. It just says simplify, and pretty much that's it. Of course, you're always looking to make sure that something makes sense or not. So there's a few tricks in here. So some of these ones here, we're going to do the ones that are highlighted, but some of the ones here may or may not, some of them here may not actually make sense. So as we do them, perhaps you can identify the ones that won't make sense. So we'll start right from the beginning here with A. If we do need calculator work, I'm going to ask for you to do the calculator work if you don't mind. So I'm relying on your calculator skills in the chat. Much appreciated. So hopefully the first few don't require too much calculator work. Does the first one make sense? And if so, what is the answer? So what I'm expecting from you in the chat is it either an answer or it does not make sense. So that's what I'm expecting from you in the chat. 14 centimeters is good to me. That's right. Nothing to see here. Oops. How about the next one? Does the next one make sense? And if so, what is the answer? Okay, it does make sense. And the reason it makes sense is because these guys here, if you multiply them, you get a volume. 6 times 8 times 10 is 480, and that's centimeters cubed. Thank you, Nicolos. We have here 380 centimeters cubed. How about the next one? How about G? Any other suggestions on that one? The answer is not 10. Oh, we have a red flag. Wait, wait, wait. It does not make sense because you're trying to do inches cubed plus inches squared. That makes no sense. You're adding a volume to an area. Can't add volume and area. That is an illegal operation, illegal request. So that's what I mean. You might get a question here that makes no sense. What about K? What about K? It's illegal. Joseph's gonna write me a ticket now. Damn it. Does not make sense. Can't. Whoops. Yeah, I know. Can't subtract hours, or I'll say time, from length. How about that, okay? You can't subtract time from length. Uh-oh. As long as, if my phone rings right now, right about now, I don't know, usually between 10 and noon, it's the telemarketers come up. You know what I'm talking about? The numbers that are all over the place, and you're like, I don't know anybody in Colorado. What? No offense if anybody in Colorado ever hears this lecture, but yeah. Anyway, okay, let's try this one. Maybe this one works. You might be like, okay, this one looks a little bit extensive, but don't get too scared of it. We'll just kind of go through the steps here, and hopefully it takes us somewhere friendly. So on the numerator we have 3 meters cubed. So if we write that out 3 times, I'll write it out 3 times. It's fine. You don't have to write it 3 times. You can just cube both of them, but it's all good. Don't mind me for a second. I just got to do some housekeeping here. Okay, talk to me here. What does the numerator become? Anybody have a final one for the numerator there? What does this become here? What's the highlighted quantity become? So what's 3 meters by 3 meters by 3 meters? Thank you, Nicholas. 27 meters cubed. And what's 2 meters by 5 meters squared? So 2 times 5 is 10. Thank you. Then you have meters cubed. And on the bottom, 4 meters and 1 meter is 5 meter. So before we proceed, is this operation possible? Is this legal? Can we do this? Can we simplify this? So what you're looking for is primarily that the addition is correct. So in the addition here, we have volume and volume. And yes, you're allowed to add volumes together. So we can indeed proceed. That's what I'm referring to in terms of, is it possible or legal or whatever you want to say. So we're going to have 37 cubic meters divided by 5 meters. If you divide meters cubed by meters, what are the units in the answer? What would the units in the answer be? What's meters cubed divided by meters? Ultimately, what do you get? Thank you, Tamirlan. Yes, meters squared. Whoops. And 37 divided by 5 is 7.4. Any comments on that? Who agrees with the answer? Oh, there's a typo. Yeah. Sorry, I just noticed the typo right now. That's my apology. As I was thinking about it, I go, something's up here. I think I was reading something wrong. That makes more sense. Thank you, Sheldon. I saw the subtraction and I wrote addition by accident. That's okay. I sure as heck wasn't trying to test you. So it was an honest mistake. No sneaky moves on my part here. Okay, let's take a look at the next one. So here we have inches to the 4 on the top and inches to the 4 again. And then on the bottom, we have some bed mass happening there. I'm going to start with the bottom. I'll start with the bottom. What's 3 squared minus 2 squared? Well, that's 9 minus 4 inches. And on the top here, we have 3 inches by 3 inches by 3 inches by 3 inches. You can write it 4 times if you want, no problem. I have no problem writing it 4 times. And I'll do the same with the 1 inch as well. You do not have to write this much, okay? If you want to just use your exponent laws, feel free to do so. All right. What does the numerator become? What's 3 by 3 by 3 by 3? You get 81. And 1 by 1 by 1 by 1 is 1. And then 9 minus 4 is 5. That's okay. We're getting there. So 81 minus 1 is 80. And you're allowed to subtract them because they're the same units. And at this point, you're almost done the question. I'll just write it over here because I'm running out of space. So 80 divided by 5 is 16, and that's inches cubed. Now you might be like, you know what? I've never seen inches to the 4 in my life. You might be like, I can't visualize inches to the 4. And that's okay, because inches to the 4 is not something that you can draw very easily. I will say this though, there are units, especially when you deal with strength of materials and physics of materials specifically, where you get units that represent strength of the material or information about how the material might bend, and you do get units that are like inches to the 4, and you do get weird things like that that are outside of length, area, or volume in terms of dimensions. So just keep that in mind, that even though this question may appear impractical to you because of the units being something outside of your experience, they may potentially represent something that is actually valid, or something that is not just valid but actually useful. Okay, number two, I think. I think two is going to be our last question for today in terms of new material, and then I'll talk about the test for the rest of class. I'll just keep it there so everybody can read it. Hopefully is that size okay? Can you still read that? If anybody's copying, let me know. Okay. Use a calculator and the rules for manipulating quantities to simplify the following expression. And then by the end of it, you're going to get an answer. And then we're going to figure out what physical quantity that represents. So let's take a look and kind of break things down here. So I'm gonna just highlight different pieces of this, and then when we finish the question, I'll also highlight those parts of the answer. So when I'm looking at this, I see four pieces to it. I see this, 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 and I see, I'll do that one. I ran out of colors, so that one I'll just leave it white. It's fine. Okay, so we have the yellow part. What does the yellow part simplify to? Well, if you look there, we actually have two operations there in the yellow. We have 3 times 4 inches, which is 12 inches, plus 5 inches. So that part is the yellow part. So it's not quite finished. So we will come back to it shortly. Then we have the blue part, which I'll just, I need to put brackets around this. Let's put some brackets there. Then we have here 100 pounds. Now in the denominator, we have the big brackets, and then we have the green part, and then the white part. I'll do the green part here, and then I'll put a plus sign, and I'll put the white part there. The green part is 4 by 5 by 6. So what's 4 inches times 5 inches times 6 inches? What do you get there? What's 4 times 5 times 6? Thank you, Nicholas. 120 cubic inches. Well done. Oops. I hit a space there by accident. And then we have here 5 inches all cubed. So remember we said that's 5 inches, 5 inches, 5 inches. I know that I'm writing it out this long way and it might be like irritating to some people. You do not have to write this extra that I'm doing. I'm just trying to help people that are having a tough time with exponent laws not get too messed up. Plus, it's okay to write a little bit extra because small steps help you prevent big mistakes. So 17 inches. Sorry, it just scrolled up on me. And then 5 by 5 by 5, thank you, Nicholas, is 125 cubic inches. So it looks like we're getting somewhere because the denominator simplifies to, what does that become there? 245? 245 cubic inches. All right, think about what to do next there. So it looks like we have inches on the top here and inches cubed on the bottom. Any suggestions on what happens to those inches? What happens to the units for the inches? Can someone make a suggestion about what to do? It's a very quiet morning, it feels like. Hopefully, hopefully you don't have too much of a dangerous day today. Yeah, you're gonna divide them out. Yes, I'm gonna leave the two. I'm just focusing on the units for a second, just the units, okay? So you see the inches here. These inches are gonna cross out with the inches there, and you're gonna get inches squared. That's what I was trying to say. So now what I'll do is I'll separate the numbers, and then at the end I'll just have here pounds per inches squared. And then you do the number stuff, okay? So what's 17 times 100 divided by 245? What is 17 times 100 divided by 245? What do you get for that? That's correct. Can we get 3 significant digits on that? Because the question says 3 sig figs. 6.9 is what I got as well, Nicholas. I got 6.94, I think, when I did on my calculator. Thank you. So that's the answer to the question. But it says here, what type of physical quantity? So let's talk about that now. So we have here 6.94 pounds per square inch is our answer. But what is the physical quantity? So when you have pounds over an area, I think many of us had mentioned that earlier. I saw at least 3 or 4 people say it. It's pressure. Because PSI is the same thing as that. See, that's 6.94 PSI. So the physical quantity here is pressure. It also can represent stress. But pressure is the primary one that most people would be expected to have familiarity with. All right, that's enough for the lecture today. We have about 20, 25 minutes, and we can spend most of that time discussing the test.